All right, we're looking at more properties of polynomial functions. So today we're learning about the multiplicities of zeros of a polynomial function. So a bunch of graphs here. The graphs of several are shown. They all are related to y equals x minus 2. They all have different exponents on that binomial factor. So the first one is linear because the exponent is 1 on that binomial factor. Okay, so it's just a linear equation. Y-intercept is -2, slope is 1. Okay, so it crosses the x-axis at 2. Okay, that's called the zero of the polynomial function, or the x-intercept. Next one, the exponent is 2, x-intercept of 2, or 0 of 2, but look at the shape. Now it's a parabola, right? We've learned about quadratic functions. It's U-shape. Next one, it's an exponent of 3. Now, still has an x-intercept of 2, but it's kind of a zigzag shape, okay? When you get to calculus, you call that point a point of inflection. So, kind of where the graph is increasing, then it levels off at the x-intercept, and then starts increasing again. Okay, so it's kind of a zigzag shape. Exponent of 4. Looks kind of similar to the exponent of 2, except it's kind of wider at that x-intercept. Exponent of 5, x-intercept of 2, kind of looks like exponent of 3, but again flatter. Okay, so flatter at that x-intercept. Okay, and then exponent of 6. Same x-intercept, again flatter at that x-intercept. So some patterns are happening here. The graphs that have even exponents, so 2, 4, and 6, all have that U shape, okay? What we call that is the graph is tangent to the x-axis, or the x-axis is tangent to the graph. Tangent means it just touches once. Different context than trig when we're talking about tangent. So a tangent line is a line that just touches another curve, okay, or vice versa. So even degree has that case, okay, where it just touches the x-axis, it's tangent to the x-axis. Odd degree passes through the x-intercept, but if it's degree 1, it passes straight through. It doesn't have that point of inflection or change in the shape. This degree 3 does. It flattens out a bit, and certainly degree 5 even more so. Okay, so says the binomial x minus 2 is a factor of the polynomial function shown above. The x-intercept of all of these is 2. There's a relationship between the exponent on the factor x minus 2 and the shape of the graph. Use this relationship to predict the following. When you graph y equals x minus 2 to the 7, would it look similar to what graphs? So that's an odd degree. It would look similar to the graphs of y equals x minus 2 cubed and y equals x minus 2 to the 5th. Not x minus 2 to the 1, because that would go straight through. Odd degree greater than 1 has that leveling off. Exponent of 8 is an even, so that would be similar to y equals x minus 2 squared, y equals x minus 2 to the 4th, or y equals x minus 2 to the 6th. Okay. So for the n, describe the behavior of the graph at the x-intercept. If n is even, the graph is tangent to the x-intercept at x equals a. So it just touches, and it looks like a U, so it's U-shaped. If n is odd but not 1, the graph passes through the x-intercept at x equals a, and has what we call a point of inflection. And then its non-math word is zigzags. Okay. So then for degree 1, so basically the same, passes through the x-intercept at x equals a, and that's it. So directly through. No change in the direction, so it's not zigzagging through. Directly through the x-intercept. Okay, it's actually a straight line. For this case, it might not always be exactly a straight line, but it's never changing from leveling off to going steeper again. Okay. All right. Set here. Okay, so there's a polynomial function, so we're going to go through this to come up with the equation. X-intercepts, so they're at -3 and +1. Corresponding factors then are x plus 3 and x minus 1, opposite signs. So the shape at x equals -3, that's that U shape. It's tangent to the x-axis. So indicates an even exponent on the factor of x plus 3. Here it has that zigzag leveling off. All right, so that indicates an odd exponent on the factor x minus 1. So here it can be written, we're going to fill in with the exponents. Take a look, it says if they represent the smallest possible natural numbers, those exponents. Because really there could be an infinite number of odds or evens. So we're going for the smallest. And so for x plus 3, smallest even is 2. X minus 1, smallest odd that zigzags through is 3. You can verify with your calculator on your own. Those values of -3 and 1 are called the zeros of the polynomial function because when each value is substituted in, the resulting y value is 0. It can be said that the function shown has 2 zeros, -3 with a multiplicity of 2. So this is new terminology that you now have to use. Another 0 is 1 with a multiplicity of 3. So basically, when you say that in words, you can figure out what the shape of the graph looks like. The degree can be determined by adding the multiplicities of its zeros. So 2 plus 3 is 5. Okay. So let's sketch some. So here's the equation. Obviously you have a graphing calculator, so we're not going to ask you to graph too much. It's more, we're going to give you a graph and you have to come up with the equation of that. In any case, the zeros here, for each factor, that would be positive 1/2, -3, and +4. For the 1/2, there's an exponent of 1. It's not shown, but it's understood to be 1, which is odd. -3 has an exponent, so that has an exponent of 2, so it's a multiplicity of 2, which is even, and then multiplicity of 3, which is odd. So the degree is going to be 1 plus 2 plus 3, which is 6. Sign of the leading coefficient. So you want to look at each x term and what exponent it is. So this is 2x, so nothing changes because the exponent is 1. X squared is x squared, x cubed, so this would be equal to 2x to the 6 plus a whole bunch of other terms. So that's a positive leading coefficient. The y-intercept is when you put 0 in for x, so that's going to be -1 times 3 squared times -4 cubed. So what's 9 times, so here, okay, so 9 times -64 is negative 576. Sorry. And the end behavior. So if it's a positive leading coefficient, it ends in quadrant 1, up. And where does it start? So if it's an even degree, it's got to be up as well. Okay, these have to be the same. And they would be horizontal quadrants, so that would be quadrant 2. So when you sketch it, start with your x-intercepts. Okay, so negative 3, 1/2, and 4. Y-intercept, notice the scale is going to be crazy. We're not going to have equal scale on each. We know that we're ending up, starting up, and so think about the degree. So at 4, the multiplicity is 3. So you have to try your best to zigzag through. Then at 1/2, it goes straight through. And I obviously did the y-intercept should be positive. I missed the negative 1. Okay, so positive. And then it's got to come down, and at y equals negative 3, it's got to be U-shaped. And then back up. Okay, so this would be 576. And this would be that. Okay, so notice the difference between the shape at those. This is a zigzag here, and this is straight through. Okay. Next one, if there's an x out front by itself, nothing's been added or subtracted, so there's a 0 of 0, then 2, and then negative 2. So the exponent on x is 1, which is odd. Exponent on x minus 2 is 2, so multiplicity is even. Exponent on negative 2 is 2, so that is also even. So the degree is 1 plus 2 plus 2, which is 5. Sign of the leading coefficient, so that's negative x times x squared times x squared. So this would be equal to negative x to the 5th, plus a whole bunch of other terms. So that's negative. Y-intercept, well, take a look. If x is 0, then you don't even need to do anything. The whole thing's going to be 0. And the end behavior, so if it's negative leading coefficient, it's going to be going down in quadrant 4. Then if it's degree 5, remember diagonal quadrants. So that means up in quadrant 2. Okay, so then label your x-intercepts. Okay, we're going to be negative here, and at 2, it's an even multiplicity. So we're going to want to make a U shape, then it goes straight through, and then another U shape. Okay, should probably fix that a little bit here. There we go. Okay. Next one, partial graph is shown, assuming minimum multiplicity for each 0. Complete it. So negative 2, 1, and 2.5, which we want fraction form, which is 5 over 2. So the zeros are negative 2, it's U-shaped, so it's multiplicity of 2. At 1, it zigzags, so 3, and at 5 over 2, it goes straight through, so 1. Where is P of x positive? So P of x is like your y values. So what has positive y values? All of that part of the graph, but not at the actual x-intercepts, right? Because a positive isn't a 0. So in a way, it's all of these values here, which is going from 0 up to, oh, no, we're looking for the x's. So between 1 and 5 over 2. So, oh, not the domain, so we can just list it. So x between 1 and 5 over 2. So 1, 5 over 2, x like that. Where is it negative? Well, that's all the other parts except for at negative 2, right? Because that has a y value of 0, and so we don't include that. So this is this left-hand, so there's basically a bunch of parts. That part, and the part at the end there. So that is x less than negative 2, and then between negative 2 and 1, and then greater than 5 over 2. Okay, now this part here, you could show it as x less than 1, and then x not equal to negative 2, because it's really just 1 point taken out of x less than 1, and then you still have to keep in the x greater than 5 over 2. Looking at this, it ends going down and to the right in quadrant 4, so it's a negative leading coefficient. So what's it going to be? Actually, it's called p of x, so we're going to call it p of x. And our factors will be x plus 2, x minus 1, and then remember 2x minus 5. We're not going to use any decimals. Exponents on these. So at negative 2, it's a multiplicity of 2. At 1, it's 3. And then 1, we don't have to show that. You do want to check to see what the a value is. So we can look here at the y-intercept. It looks like it's at negative 20. So if we put 0 in here for x, we would get 4 times negative 1 cubed times negative 5. And that is positive 20. This needs to be negative 20, right? So a has to be negative. Right? So, and we knew it had to have a negative leading coefficient, but sometimes there's a stretch factor as well, right? So that is your completed polynomial function. Okay. Multiplying an equation by a constant. So we've got the partial graph, which means just the main parts of the graph of that function. Use your transformation skills to accurately sketch the graphs where we multiply by 2, multiply by half, and negative half on the same grid. Use different colors and label. So if we take our original, just like we did with quadratics, and we multiply by 2, then every original y value gets multiplied by 2. Now y value 0 doesn't change. So those points are going to stay the same. But for example, this maximum here is now going to be at 8. This y-intercept at negative 6 is now going to be at negative 12. This minimum just less than negative 8 is going to be at negative just less than negative 16. Okay, so we can kind of see what's going to happen. It's going to be stretched out. So here, yikers, just a sec, use pencil. My smartboard is getting misaligned. Okay, so that is y equals 2. Okay, then for a half, use green. That's going to stay, that's going to stay, that's going to stay. The original y value 4 is now going to be 2. Original y-intercept of negative 6 is going to be negative 3. Negative 8 is going to be negative 4. And we can go from there. You can do more points, but this is going to give you an idea. Okay. And then negative 1/2 would just be the reflection of that. Okay, so that's going to be down here, negative 2, and positive 3, positive 4, and 0. right, so complete the following statements. Multiplying a polynomial function by a constant causes a vertical stretch of the original graph. If the constant is negative, then there is also a reflection in the x-axis, or the line y equals 0, and the invariant points are the x-intercepts. Okay, so next one, algebraically determine the factored form of each polynomial function. So a quartic is degree 4. You'll notice we have 4 zeros. So they're all going to have multiplicity of 1. So we can set up, we don't know what the leading coefficient is, but we know the factors. So x plus 2, x minus 1, 3x minus 1, and then 2x plus 3. And it passes through the point 2, negative 70. So you're going to put negative 70 in for y, 2 in for x, and solve for a. Okay, so that's going to be 35 times 4 is 140. Okay, so then a equals negative 1/2. And then always rewrite your polynomial function with the a value in there. Okay. Next one, it's a cubic function that touches the x-axis. So that means it's tangent to the x-axis at x equals 3. And then it crosses the x-axis at negative 1/2. Only choice here, because it's cubic, is degree 1. Okay, so this is a multiplicity of 1. This is a multiplicity of 2. So we'll have y equals, again, we don't know the stretch factor. If it just touches at x at 3, then that's x minus 3 squared. If it just touches at negative 1/2, then it's 2x plus 1. And then y-intercept has coordinates 0, 36. So substitute, so 0, 36. We put 36 in for y, 0 in for x. And simplify that, so a is 4. And we rewrite it with that leading coefficient, or the a value of 4. Wouldn't actually be the leading coefficient because of that too. Okay. And algebraically determine the factored form of the equation of the polynomial function shown. If the multiplicity of each zero is the lowest possible value, state the degree. So you want to look at each x-intercept here. Okay, so that x-intercept is negative 1.5, which as a fraction is negative 3/2. That's 0, and that's 1. Okay, this goes directly through, so that's a multiplicity of 1. This zigzags through, so multiplicity of 3, that's a U-shape, multiplicity of 2. So y equals, we don't know what the stretch factor is, so a, and then, so negative 3/2 would be 2x plus 3, goes directly through, so then the exponent is 1. Then x, zigzag, so that's going to be x cubed. And then x minus 1 squared. So when I do my final answer, I'm going to put the x cubed in front. But for right now, I can just leave it because I need to find out what a is. So then you want to look for another point, a nice point that's not one of the intercepts, x-intercepts. Y-intercept's good, except we've already used it in the x-intercept. So if you follow along here, it looks like this is a good point. So negative 1, 8. Okay, so negative 1, 8. So don't estimate to, like, don't use decimals. We'll probably point a nice one out if it's hard to see, but don't just estimate. So 8 equals A, 2 times negative 1 plus 3, negative 1 cubed, negative 1 minus 1 squared. Okay, so that's going to be negative 1 times 4 is negative 4a, so a equals negative 2. Now when I write it, I put negative 2 to start, then I'm going to put my x cubed, then my 2x plus 3, then my x minus 1 squared. Okay. All right, and then the exercises and the answers are there for the exercises. So you're done.